Hello everyone, welcome back to our channel NotesNaka. Today I am going to discuss how an AI, that is artificial intelligence, can solve a maze using depth first search and breadth first search. Here, our goal is to reach from the initial state to the final state, that is the goal state, and we are going to use uninformed search, that is the search strategy that uses no problem specific knowledge. For example, DFS and BFS to solve today's maze problem. The algorithm for such search goes as follows. Start with a frontier that contains the initial state. Start with an empty explored set and repeat. If the frontier is empty, then there is no solution. Remove a node from the frontier. If node contains goal state, return the solution. Add the node to the explored set. Next, expand node. Add resulting nodes to the frontier if they aren't already present in the frontier or the explored set. This is the algorithm we follow. Now, moving on to depth first search. This is the search algorithm that always expands the deepest node in the frontier, and we use stack, that is a last in first out data type, to implement depth first search. Let's see how this works out in our maze. Our initial state is given by the white king and the final state is represented by the black king. We can go in any direction, top or right, from the initial state, as we have established no such preference at the start. Let's start with the right tile as compared to the initial state. As this is depth first search, we go and explore the deepest node first, and we continue exploring in the given direction. We have now traced out a good enough path by this algorithm, and also we have found the goal state without any trouble, and in this case without excess computation. But what if we had begun exploring from the top tile of the initial state? Let's try this out. We would have found the goal state even if we had started from the top tile, but we would have ended up finding a path which has more path cost, that is numerical cost associated with the given path, than the previous path, that is 9 steps instead of 7. This means it's not always necessary that we find the optimal solution with that is the one with the least cost while using depth first search. This finishes our discussion on depth first search and how it is not the best means if we need to find the optimal path at any cost. So now we move on to BFS, breadth first search. This is a search algorithm that always expands the shallowest node in the frontier and uses Q, that is a first in first out data type, for its implementation. Now let's see how BFS performs on this maze. In this algorithm, we start, let's say, with the right node to the initial node. Then we go on to explore the top node with respect to the initial node, as this algorithm explores the nearest nodes first. So we alternate between the two paths, which we saw in the two cases in DFS. Here we can see that we reach the goal state with the shorter path cost, that is the one with the least path length, the optimal solution. But this algorithm works well only if the goal state is comparatively nearer to the initial state, or we might end up looking at thousands of paths alternatively instead of going down one which promises the goal state. So, when should we prefer using BFS and when we should use DFS? BFS, or breadth first search, is more suitable for searching vertices which are closer to the source, as we have seen in the example, and DFS, depth first search, is more suitable when there are solutions away from the source, as it tries out path to the very end, ensuring that this path either does have the goal state or doesn't have the goal state. And breadth first search considers all neighbors first and therefore is not suitable for decision making trees used in games or puzzles. While DFS, depth first search, is more suitable for game or puzzle problems, as we can make a decision to explore all paths within this decision, and if this decision leads to a win situation, we stop, which is clearly more suitable in case of depth first search, as it exhausts the whole path till the end. This was all about depth first search and breadth first search and how they can help you solve, or an AI solve, a maze. You can make mazes such as these at home and try different combinations of the paths and different algorithms to solve them and find out which works best in which case. Thank you for watching this video of NotesNaka. Like this video and comment on which kind of videos would you like to see next, and subscribe to our channel and turn on the notification to get notified whenever we upload a new video.